right, let me do this next two questions together. They should be relatively simple questions, just simple application of Newton's second law. I do have to add the forces in 2D, I think. That's how I group the questions. So let me start out with a free body diagram that helps me make sure I understand the physical setup as it's set up. I have a particle of some mass that I am given, 2 kilogram, that experiences these following three forces. F1 is purely in the x direction. So, and let me say this is going to be my x direction. So F1 this way, and F2 I had that still x direction, but there's a minus sign, so it's going to be in the opposite direction, F2. And then F3, J hat, it's in the y direction, so something like this, F3. So those are my three forces. I think I understand. I can calculate net force easily enough. Net force is equal to these forces as vectors, and I guess you could actually just to do that, substitute these in, do the algebra. So F1 as a vector is 20, presumably newtons, I hat, plus the F2 as a vector is minus 16, presumably newtons, I hat, plus F3 as a vector is 4.5 newtons, J hat. Now you can collect like terms in terms of the unit vectors, I hat and J hat. When you do that, you get I hat, the x component, times the sum of these two. So 20 minus 16 plus J hat times just 4.5. So this is your net force. Now, if they were asking us for net force in the component form, we would put that in. Now, they're not asking us that. They're actually asking for acceleration and the magnitude, not the component form. So this is where you have to remember Newton's second law, and remember that net force is related to acceleration through this mass times acceleration, or solving for acceleration. Acceleration is equal to net force divided by m. So I think I can do the rest of this in a calculator, because for the acceleration that I need, the magnitude that I want, I just need to take the magnitude of this thing, which is going to be basically just the x component squared plus y component squared, square rooted from the Pythagorean theorem. And with that in mind, I think I can do the rest in calculator. So I have 20 minus 16, so that's 4 newtons, divided by mass, 2 kilogram. This is my x component of acceleration, square it, plus, do the same thing, 4.5 newtons, divided by the mass, 2 kilogram. That's my y component of acceleration, square it. I've added them, take the square root of those two squares. That's going to give me the magnitude of acceleration, 3.01 meter per second squared. Good. So pretty simple. You do the vector addition and then simple application of Newton's second law. Let me get to the next question. All right, so this is the next question. I think that's a question. Let's see. Oh, I gotta move this a little. 39. It says, find the acceleration of the body of mass 20 kilograms shown below. Oh, it's can I reuse this? Well, I think it's gonna be, let me move the figure and just to redraw this as F3 that's pointed downward. So F3 pointed downward. And I think with a few changes of numbers, we can basically use the exact same thing. So the mass will be, instead of 2 kilograms, it'll be 20 kilograms. And when we are now actually plugging in the numbers, it'll have to be, instead of 20 newtons for F1, let me label them just so it's clear. F1, F2, F3, and just trying to reuse my figures. Instead of 20, it'll be 10 newtons. And instead of minus 16 newtons, it'll be minus 2 newtons from F2. And then instead of 4.5 newtons, it'll be minus 4 newtons. And then and here they are actually asking for the components, so we can do a little bit less now. So when I take these differences, so this is 10 minus 2, this is minus 4. If you simply plug this in here, 8 and minus 4, it'll say it's wrong. Because it is wrong, you have to make sure you are answering in acceleration. These are the force components. They come in unit of Newton. So you have to go through this here, divide by mass to get the acceleration. The part you don't need to do is this taking the magnitude, because they are asking us for the component. So each of these numbers, 8, I need to divide that by 20. I think I can do that in my head, 0.4. And minus 4, I need to divide by 20. I think I can do that in my head, 0.02. So, wait, is that right? 0.2, I think. Let's give it a try. Good. Yeah, so that's it. You just have to make sure you add the force vectors by components, and make sure to use Newton's second law to relate it to acceleration, which they're asking you for.